Okay, so now we're going to do special factoring, and it's not that it's any harder, it's just a little different. You have to recognize it when it shows up. So the first one is perfect square binomials. So that's when you have basically two terms. So two terms and it's a difference, meaning subtraction. You need to check for, first thing always is GCF to factor out. Every single one, you should be factoring the GCF out. So, put it away. Okay, so then once you've checked for that, the first term is a perfect square. Okay, the second term is a perfect square. And they are separated by a subtraction sign. This is the only time this happens. The middle term is absent because it is canceled. So, or it is 0, meaning there's nothing there. Okay? So, factoring a perfect square binomial results in two similar binomials that differ only in the sign. So in the plus or minus sign, I'll put. Okay, so again, to start to factor, you should always begin by looking for a common factor. And the other thing is make sure that the leading coefficient is not negative. So you should factor it out to start. The first term of the binomials comes from the square root of the first term. So for instance, if I'm looking at this right here, this x squared minus 16y, do you see that I'm square rooting the first term? Okay, so what would be the square root of x squared? X. So x goes in the first spot right here. Does everybody see what I'm doing? Okay, the second term comes from the square root of the second term. So what's the square root of 16y squared? 4y. So I put 4y here, and I put 4y here, and then place a positive sign in one of the parentheses and a negative in the other. So plus, minus. Does everybody see that? And so why does this actually work to factor? So let's actually FOIL this out. Again, x times x gives us x squared. Outer gives us minus 4xy. Inner gives us plus 4xy. So do you see that those terms cancel each other or zero out? And then, of course, the last term is minus 16y squared. So once you know this happened, like now that you've seen it, if you ever see two terms and it's a subtraction, always look for this to factor. So then it's really fast factoring. So does everybody see? Two terms and it's a subtraction. So what's the square root of the first term? 2x. So you put 2x in both of them. What's the square root of 9y squared? 3y. So put 3y there. One's a plus, one's a minus. FOIL to check. Do you see that the outer and the inner term will cancel each other? And you're left with what the question is? Yes? Okay. Let's try the next one. What's the square root of 225b squared? 15b. So hopefully you know your perfect squares. What's the square root of a squared? A. One's a plus, one's a minus. Does it matter which order I put these in? No, doesn't matter. Okay, next one. What do you get there? Okay, so I tricked you. This only works. This only works when this is a subtraction. That's why it's called the difference of squares. So does everybody see? The reason why it works is when I do that second term, the plus a times minus a, that's how I'm going to get the minus a squared. So if you think about this, how would I get plus x squared? Well, the only way I could get that is a minus x times a minus x or a plus x times a plus x. Same with the 7 or the 49. So you might say, well, then it's 7 plus x times 7 plus x. Would that cancel the middle term? What's significant about canceling the middle terms? they have to be opposite signs to cancel. So that means this is not factorable. Okay? So sometimes it's written like this. Okay? Remember, I just finished saying you should never try to factor when the leading coefficient is negative. So what can be the first thing I do? Factor it out. So negative bracket y squared minus 36. Do you see that? Do you see difference of squares now? Yes? So minus bracket, I don't have room there. So what goes in the first one? I'm sorry? Yeah, y plus 6, y minus 6. Okay. Let's keep going. Number 5. It's 2 terms and it's a minus. However, you cannot square root 3. It's not a perfect square. However, what's the first thing you should always try to do before you do that? Yeah, you need to factor out a common term. And if the leading coefficient is negative, you need to factor the negative out with it. So what is the common factor I need to do first? A 3x. And then I'm left with x squared minus what? 16. Then I look at this. Can I factor that? Yes. Okay, now this is the mistake people are making. They forget about the 3x. Remember I said you need to drop it down with a line if you're going to like leave it for there. But why wouldn't you just go to 3x bracket, 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 bracket and keep it in there? Some people are just ignoring and it goes away. That's not how it works. It has to multiply out and get the original function, right? So what is x squared minus 16 factor to be? Yeah, x plus 4, x minus 4. Very good. Okay, so on the quiz, there was a part where this part couldn't factor anymore. That doesn't mean it's not factorable because you factored out the common factor. So sometimes you can just factor out the GCF and then you're done. But you factored it. It's not because it's not factorable. It's just you can't factor anymore. Okay, this is a subtraction and 2 terms. Are they both perfect squares? Yes. So what is that factor to be? X squared minus 4, x squared plus 4. Can you factor again? Yes. Do you see there's a difference of 2 perfect squares? So that gets factored even more. So x squared plus 4 cannot be factored anymore, so I'm just dropping it down. What does this factor to be? Yeah, x plus 2, x minus 2. So if you ever get down to 2 terms like that, right, you got to watch for it. Can it be factored again? Sometimes you might have to factor 3 times because you can keep going, right? Again, GCF factoring, that's factoring. Then check the middle, like or the second term that you have left. If you can't go any further, then that's your answer. You might even keep going, right? So you got to look for all that because it has to be factored completely. Okay, moving on. Now we're going to do perfect squares. This one's harder to see, and honestly, a lot of the kids don't see it until grade 11 when we're doing it all the time. But if you can spot it, it's really fast to factor. So a perfect square trinomial has 3 main features. Okay, the first term is a perfect square. The second feature is the last term is a perfect square. And the sign of the last term is always positive. Okay, so if you look at this, just so far so good. The first term is a perfect square, the last term is a perfect square, and this is a positive sign. Okay? So the middle term can be positive or negative, and if it's negative here, that means when I factor it, it's a minus times a minus. If it's a plus there, then I know it's a plus times a plus. It's always double the square root of the last term. Okay. So factoring a perfect square trinomial results in two perfect squares. Okay, so if you recognize that this is a perfect square, this is a perfect square, this is a plus, then try square rooting it, right? Okay, so I'm going to put it like this. So I put an x and an x and a 4y and a 4y. Okay? So do you see, in order to get a minus there, this has to be a minus and a minus. Now notice why this is a perfect square. What is really this times this? Well, it's really that square. Do you see? That's why it's called a perfect square. So if you've seen this once, you could go directly to this step. And you might ask, do I have to write it like this, or can I just leave it like that? This is acceptable like this. But if you can recognize this is actually a perfect square, so I'll go through this again. The first term is square rooted. The last term is square rooted. And then, do you see the first and the last, it's double that for the middle term. Do you see? X times 4y is minus 4xy. Double that gave me the minus 8xy. Why do I get double? Because do you see when I do an outer and an inner that I have two of the same things? Okay? So again, this one's a little bit harder to see. The difference of squares that I just did on this page is like you have to recognize this in order to factor it, versus this one, you could just factor like your guess and check, and you'd probably get away with not even knowing this. But it is faster if you can recognize it. So for instance, first off, I don't like the way this is written. You should always write it in descending order. So x squared plus 14x plus 49, right? So can I take any GCFs out of that? No. Can I recognize that this is a perfect square, and this is the first term is a perfect square, the second term is a perfect square, and it's a plus? Is the first term times the last term square rooted double that the middle term? Yes. So this is x plus 7, the whole thing squared. So that's what I'm saying. It's fast if you can recognize it. If not, then just play around with it, the guess and check, until you get it. So again, I'll repeat. The first term square rooted. The last term square rooted. The outer and the inner is the same, so that you have two of those. That gives you the middle term. Does that make sense? Okay. Next one. 5b cubed minus 40b plus 80b. So you might not recognize what this is. You're just going to get this question and you're going to like, holy smokes. But what is the first thing you have to do first? Factor the GCF out. So what should I factor out? A 5b. Okay, and some people are skipping this step. Now they try to factor everything completely. No, write out what's left out. So 5b times what gives me 5b cubed? B squared. 5b times what gives me minus 40b squared? Negative 8b, yeah. And then 5b times what gives me 80b? Plus 16? Okay, so now what I would do is I would write this out and then write the double thing, but then go, oh, hey, wait a second. This is the b squared is a perfect square. The last one is a perfect square. It's a plus, and the square root of that doubled is that. So what is my actual answer? How would I get a middle term of negative? Yeah, it would have to be b minus 4 squared. Do you see? Again, if you were to write this out as 5b, b minus 4, b minus 4, I would give you full marks, but this is the better way of doing it with the square there. Okay? You don't have to, but it is the better way. Okay. Okay. So let's look at number 3. The volume of a rectangular prism is represented by 2x cubed minus 2x squared plus 72x. What are possible dimensions of the prism? So a rectangular prism, how would I figure out volume of a rectangular prism? Do you know what a rectangular prism looks like? you know, it's like a box, essentially, like that. And we have a length, a width, and a height for the volume. Yeah? So, how would I figure out what possible dimensions this would be? Yeah, you need to figure out what times what gives you that. So, what would I try to do with this? What's the opposite of multiplying? Dividing. What's the same thing when we have polynomial? I'm sorry? Factoring is the same thing as dividing. It's another word for dividing. So we are going to factor this. So what's the first factor that I can take out of this? Yeah, I'm just going to write it out here. A 2x, I heard. So I'm going to take out a 2x, and I'm left with x squared minus 12x, yes, plus 36. Okay, so now this is a perfect square. Sorry, x squared is a perfect square. 36 is a perfect square. This is a plus. So does everybody know what this is going to be factored to be? Yes, x minus 6. There you go. All right. And that's all I got for this lesson. Okay.